Ideal fluid assumptions. To understand many aspects of fluid's motions, we can imagine a special kind of fluids called an ideal fluid. This isn't what a real fluid might behave, but it helps us in simplifying the analysis by assuming certain properties that a real fluid does not always have. An ideal fluid has four key properties, which are: the fluid is non-viscous, the fluid is incompressible, the fluid motion is steady, and the fluids move without turbulence. An ideal fluid assumption states that the fluid is non-viscous. Imagines the fluid having no internal friction force between its layers. This means there is no stiffness or dragging between them. In this ideal scenario, fluid particles glide past each other without any frictions and lead to a smooth and effortless flow. An ideal fluid is also incompressible. Fluid is said to be incompressible if its density remains constant regardless of changes in pressure. This is because density is defined as the mass of the fluid divided by its volume. If the volume doesn't change with pressure, then the density also remains constant. Think about water. Even when squeezed in your hands, its density doesn't change significantly. These assumptions simplify the analysis of pressure and volume relationship. The third assumption is the fluid motion is steady. This means if you were to measure the velocity of the fluid at different points, you will find the velocity is the same at each of these different locations. The fourth assumption is the fluids move without turbulence. This implies that the fluids undergo laminar flow regime. In laminar flow, the fluids travel smoothly or in regular path, with each layer of fluid effortlessly pass each other with no turbulence or mixing. These assumptions allow us to study the interplay of pressure, velocity, and other factors in a controlled manner. Basically, these simplified frameworks help scientists in understand the fundamental principle of fluids mechanics. Have you ever noticed how some liquids pour smoothly? Water, for example, while other types of liquids like honey seem thick. This difference in how easily they flow is all about a property called viscosity. Viscosity is a measure of fluid's internal frictions. It describes how much its molecules resist sliding past each other when the fluid is in motion. Imagine the fluid's molecule as tiny hand grabbing onto each other. The stronger these sticky handshakes, the more internal friction there is and the harder the fluids flow. In a high viscosity fluids like honey, there is a lot of internal frictions which make honey harder to flow. In a low viscosity fluids like water, there's less internal frictions, therefore water can flow more easily. Different materials have unique internal structure and interaction between their tiny building blocks. For example, paste has a strong intermolecular forces within them. These bonds act like a tiny hooks grabbing onto each other and resisting any attempts to flow. This is why toothpaste takes time and effort to squeeze out of the tube. On the other hand, acetone molecules are smaller and more independent. Perhaps they have weaker intermolecular forces and can easily slide past each other. This results in a much lower viscosity, allowing acetone to flow freely like water. Basically, toothpaste with its strong bond has high viscosity, while acetone with weaker bond has low viscosity, as illustrated from this figure here.